To stream today again, and I'm going to continue to try to implement the Spring physics. I'm thinking about it. I think I'm gonna have to translate everything that I have here to a class instead of doing this functional programming, but I'm not really sure about it. I don't really know what is best. I think that it might be better to do functional programming because it has more flexibility, let's say, but all of the libraries, I think, do object-oriented programming, so maybe that's a better approach because the elements in the graph are not going to change that much, I think. But it's kind of difficult to think about because I think it depends a lot on the physics engine you have and what kind of things you want to do on the animation, maybe. So I'm kind of reluctant to move everything to a class, but I think it makes more sense now from the stuff that I'm doing because then it's a lot easier and I don't have to return this thing here. I could just do like a property of the class when I initialize, and the same with a bunch of these functions. I can just make the nodes, and also because yesterday I realized that there is a problem if I click on the button to update the nodes and the edges based on the data. For some reason, it doesn't work really well. Like the thing that I don't understand really well is that it doesn't update this automatically unless I put the props on the dependencies. But that doesn't make a lot of sense to me because from the React standpoint, I think you should mount this unmount and mount this component again every time that the props change. But I think it might be happening because of the flush sync here that I put. The other thing that I realized is that if I put the flush sync there, I can't. It's not the best thing to do. Like I can't destroy the app on the children because I'm already unmounting the child components when I flush here. So it's not like it is wrong, it's just that it changes. So I just realized that now as well. So like it is, I think the solution is correct, but I think if they wanted to implement on the Pixie library itself, the React Pixie library itself, maybe it's not the best because then, or you can implement it and then just let people know in the documentation that they can't destroy the app on the children component because it's already going to be unmounted here because they're changing the order of the cycle. The other thing that I realized is that it might not be, because yesterday I said that if you change the forces inside of here, it might be an anti-pattern because from the way that this is structured, from this code here and from the Rapier JS library, it seems like it is more incentivized to initialize everything that you want to do before you enter the loop, and then on the loop you just update the drawings. But that, like I thought about it today and it doesn't make a lot of sense because it's impossible to initialize everything that can happen in the beginning because you can have a lot of complex things and you also have the dynamic of the player, which is gonna be updated. You can't have it like any other way, I think. So, but I think it does make sense to try to, I think the best approach is to try to implement as much as you can before you enter the loop, because then obviously you save a bunch of computation. So you should avoid as much as possible, I think, to change the physics forces here, because then it is more efficient. But I think in my case, I can't, I'm gonna see now if I can do that or not. I'm gonna try first to add the spring forces here. And I'm gonna follow this tutorial here. I already watched this, but I'm gonna watch again and see if I can do exactly the same thing that he's doing here, because this video is very, very good. And it's exactly what I wanna do, because the way that the simulation is there right now, it doesn't feel like right, because obviously there is no physics, even though everything's connected. So, and this one I found from VJS as well. They have a function to calculate the spring force. So if I can't do it with the video, I'm gonna try to translate this one. But the reason why I'm not sure if it's gonna work here is because I don't know if I can initialize the forces before, and then they're gonna be updated automatically for each step of the simulation. So I guess this is the thing. This is the reason why I thought it might be an anti-pattern, is because of this step. Because you're gonna call the step, and then the step function on the simulation should do the updates based on the initial position of everything. But like, it's impossible for them to structure the library in such a way that they're gonna capture everything that it can happen based on the initial conditions, I think. So I think it's a mix between the two, probably best way. Let me see if I'm streaming again. I don't think I saw. Yeah. So I'm gonna watch the video, and then I'm gonna try to implement what he is doing there. I think I'm gonna spend 1 hour, and then after that I'll take the camera off, and then I'm gonna try to spend more time. Yeah. Hopefully I'm able to finish the string physics today. Then I think I'm gonna try to do as many things as possible without translating everything into a class first, because I think I need to spend more time thinking about it. If it's like, what's the best approach, the positives and negatives, probably I'm gonna use ChatGPT to see if it says anything interesting. And I think the other thing that I'm going to try to do right after I do this is to try to implement the panning and zooming. And I think I'm just going to try to do the simplest thing that I can do, because this, just by looking at these libraries here, is not very clear. And I don't want to spend a bunch of time studying the tree. I spent some time looking at the repositories, but it's very similar to the other libraries where they have a bunch of classes, and then each class called the other class, and then you have to go this whole path to try to understand like how they are changing the view. So I think it's better to just try to do it the simplest way I possibly can directly on Pixie. See like how to change the scale, and then I set up an event listener to the canvas, just calculate the positions of the nodes, and then put an if statement to check whether or not the mouse is on top of one of the nodes, and if it is, then I move the node. I'm gonna have to search for what events. It's kind of confusing, to be honest. It seems like the tricky thing about these things is that it seems very simple, but it's very difficult to know like what is the correct way to do it.
So Hooke's law is named for Robert Hooke, a British physicist, yes, who developed the formula, this law in the 1660s. So Hooke's law was originally stated in Latin as ut tensio sic vis, or as the extension, so the force. But it's more commonly written out as an equation, and the equation looks like this. As the extension, x standing in for the extension, another word for that might be displacement, so goes the force. K is a value commonly referred to as the spring constant. So it's how stiff is the spring, how springy is the spring, if you will. To understand what the extension is or displacement is, let's draw the diagram as follows. A spring is made up of 3 things. An anchor, a ball.
Before this, let me see like what I have here. I have the front body, two body. I think the body. So let me go to the documentation, and I'm gonna see what kind of methods I can have there. See how I can. I think it's world great rigid body. And then it creates a dynamic body set translation, which initializes the position, I think. Yeah, this is the stuff that, because I want to see like what I can. I'm just gonna try to replicate what he is doing there. I don't think that this stuff is hard, but it's annoying to do it. It's kind of like I was thinking about this, like the reason why I don't like to do these things, I think, is because it's kind of like solving a set of linear equations. It's not like that it is hard, but if you tell me to solve a million sets of linear equations, then like I'm gonna be very annoyed about this. And it's kind of the same feeling I get about this thing here, is that it's not difficult, but it's very boring to do. And I don't like doing it. I'm much more interested in this stuff that's is like creative, let's say, I think.
Hi, Bob. And the spring, the pointy thing, the spring itself. This thing is really the spring. So if the spring is at rest, meaning it's not moving at all, then we have something called the rest length, which is the distance between one end and the other end of the spring, or in this case the anchor and the bob. This is the rest length. If we were intuitively, you probably understand the spring as if I were to pull it down and release, it would spring back up. If I were to contract it and push it in, it would spring back out. That contraction or that extension is the displacement or the extension. So let's say I were to pull it down to here. The distance between where this bob currently is and where it would be at rest, this is known as the extension, or in this case x. And the reason why the -1 is there is because even though the extension is positive, the spring is the force is pulling back in a negative direction, the opposite direction of that extension itself. Ultimately, I want to do this with vectors, these little things known as arrows, so that this could be anywhere, and the spring could point in any which way. But let's work it out just in a sort of one-dimensional spring, which is a single y value.
The other thing that I forgot to say is that here I tried to pass this stuff. I forgot the reason why I put the use context here instead of putting on the world component. But the reason why is because I'm using React Pixie. So when you use a custom renderer, you can't pass the context from one renderer to the other. You have to use a context bridge, like they say on the documentation. And that's the reason why I'm using the context here. And I think that this might be one of the reasons, like it would be simpler, let's say, if I could use the context here, because then I think that the issue that I'm having there when I try to update the nodes, when I click the button to update the edges and nodes, it wouldn't fuck up the simulation if I had the context here. Or I think it would be less likely to fuck up because then it's more simple. But when I'm passing as a props, then I have to put the props and the props as a dependency on this one to run this again. And I don't understand really well why. I think it might be because of the flash sync there, because it should update automatically because the props are different. So in the diffing algorithm, it should see the difference and update. But I think because I'm using the custom component, maybe that's the reason why the simulation is kind of weird or it doesn't work when I pass the stuff as a props here. So this made me think that it might be better to just let go of using React Pixie and just initialize the simulation directly. And I was thinking about like the downsides and positives of and I asked ChatGPT here of using React Pixie. And it seems like the only strong positive is just the efficient updates. And I'm not really sure how efficient it is, because the way that I was thinking before, in the beginning, is because it's very confusing, this relationship between the canvas and the updates on React DOM. But now I think I understand much better, which is that like the whole life cycle of the components are not going to run every time that there is a redrawing on the canvas, but there are some parts of the life cycle that are going to run, I think, which is the component data update and whatever happens after. I think I'm not really sure if renders happens. I think it does. It has to, because to create a new animation. So like the way that I was thinking about before is that is much more important to optimize as much as possible the updates. But now that I'm thinking about that is not that important as I thought it was. So I think like the downsides of using React Pixie are, I think it's very close, but yeah, the problem is I don't understand really well like how much of a difference these efficient updates here make. And the way that it works is that they fire an event every time that there's an update on the DOM. When you're committing the work in progress route or committing the route, then it fires an event every time, and then I think that makes it more efficient to update. But I don't think that is that much more efficient. So. And the downside is just that it adds a bunch of complexity. So I'm thinking that it might not be worth it to use that. So I might just let go of using this stage here, and that would make it a lot easier, because then I wouldn't even need this other component here, I think. So the only reason why I'm using this component is because I have to get the context from this one. And the other thing that I'm thinking about it is that when I do things like this, the event listeners for the Pixie viewport don't work. The events fire off, but they don't work. And the reason why I think is because you can use several different tickers for the app. And each ticker is going to be like its own thing, let's say. So I think that's the reason why, because like I have a console log on the events on the Pixie viewport, and they show the events being fired, but nothing happens on the simulation. And I think because the simulation is being rendered through this other ticker here. So even though the events are fired, the simulation doesn't change. And if I want to use the React Pixie, then I think it makes more sense to return from this function the, or I don't even need to return, just run the function and then use the useTick hook outside, which is going to have the same ticker, which is going to use the same ticker that Pixie viewport does. And then use that one, run the functions inside of that one. So, but I think it's more likely that what I'm going to do is just remove the React Pixie library. I think that might be a better decision, but it's one of those things that is very similar to choosing whether or not to do functions here or a class. That is very complicated because it involves everything that can happen and how things are going to go in the future. So,
which is this really basic sketch, just one variable, just y itself. So y being 200. So we'll say that y position 200, the spring will assume is attached to the top, and then the rest length will therefore be 200 or 200 minus y. So the displacement, or x, would be whatever the current y is, minus 200. And I should make that a variable. So in this case, the displacement is 0. The spring should move, which is what I see. But what happens if the displacement is not 0? Like if I make it 250? So clearly it should spring back up. So I need to calculate that force that I've got over there. And I can make up a spring constant. Let's just use the value 1 for lack of anything else right now. So what do I do with that force? How does that force change the y position? Well, this goes back to the sort of core foundational principles of my nature code series. An object has a position, the velocity changes the position, the acceleration changes the velocity. I covered that extensively. I'll link to those videos here. Other thing that's really critical about that series is Newton's second law. Force equals mass times acceleration. And if I were to simplify that law, I could just say, well, forget about the mass. It's equal to 1 for everything in our world. Force equals acceleration, or acceleration equals force. So if I were to say the velocity changes by the force.
I guess the thing that I don't understand here is how he gets the rest length, because here I can get based on Pythagoras, where like is the square of the this function here for the distance, but maybe this one is wrong, I think. Because it should be on the x and y. Should have the triangle. Oh no, but these are points. And we'll have to think about this. Because obviously it's one side of the triangle. I think this is wrong. So I should do 1 point minus the other through the power of 2, and then the square root of that is going to be the size of the... Yeah, I think this is wrong. They should only have one distance. So it's going to be 1x minus the other. That's going to be the size of one part of the triangle, and then 1y minus the other. And it doesn't matter because it's the power of 2. So even if it's negative, like it doesn't matter which one it is. And then you take the square root of that, and that's going to be the distance between the two nodes. I think I do 2 minus... this is what I mean that this stuff is annoying, is that like it's just small details and stuff like that I really hate thinking about. That's why I wanna move on from this as fast as possible. So I can focus on the stuff that is actually interesting. I think now it is correct. And I think I'm not gonna have to think too much about these things, because once you build the functions and the equations, then you can just use the equations and not think about this stuff anymore. Yeah, this is the edge length that I'm thinking about. I think that this is gonna be the edge length, so it's going to be this times k, which is going to be a constant. And then later on, I'm going to think about all these variables, because obviously I want to make everything dependent on a variable, so I can create another component and allow customization. And I think that the next thing that I'm going to do is use this library here instead for context, because it's more efficient, I think, than using use context. So I'm going to have to study this stuff here. And in this here, I think I have just set this stuff. It's on the rigid body description. Because I don't really know what damping is. Because I don't understand. Maybe I should look in the translation. But I think it is related to the resistance of the spring. So if you just leave without any resistance, then it's just goes back and forth forever. But if you put some sort of resistance, it's kind of like air, that the system loses energy over time. And that's more realistically, obviously, because that's how it works on reality. So it eventually it stops the movement. And this is the stuff that I was thinking about yesterday as well. That's like it felt off. I knew there was something that I wasn't thinking about, but when you put the two different forces, like that, I said that if you put in order to simulate the string, you have to put it. I could put two different forces, and then just make the force, one force greater than the other, obviously, and that would create the effect of attraction, obviously. And I could regulate how fast they would go based on the differences of the forces, but then obviously, if you just put it like that, then they're just gonna collide forever. So, or they're just gonna collide and stick together because there isn't anything that makes them go back, so or stop moving if there is no mass. And then if there is mass, they're only going to stop moving if there's gravity, obviously, because then it becomes a vector because you have gravity pointing down and the force is up, and then you're going to have a vector that is going to dictate the movement. But yeah. So maybe I'll comment this and I'll see if I need it later. And the other thing that I have to do here, I think, is I think I'm gonna wait for this actually, just see if I'm gonna use the collider or not. But if I don't use them, I'm gonna refactor. So it just connect the ID connected to the body. Maybe it is worth it to. I think I can loop if I make an asset object from the nodes. I can loop using object of values, and would be the same thing. So I think I might do that actually, because then it's more efficient. I just initialize the node, and the only thing that I'm gonna have to change is the graph, the way that I'm structuring the graph. So I got the correct data structure. I think the reason why I did a list of nodes is because PyVis, which is the modification of network X, does like that. And I think the reason why they do it like that is because there's nothing that guarantee on the structure of the nodes that you're gonna have you're always gonna have a unique ID. So I think that's the reason why they use a list of objects instead of making nested objects. But I think for my case, it would be better to. I think it's always going to be better to have always have a unique ID because I control the creation of the graphs. So in PyVis they don't control because there are several applications. So I think it changes it slightly. What's better? So, but yeah, this is the difficult thing. This is why I think I'm spending a lot of time trying to solve these things, because like they're easy to solve, but it's very hard to understand or to think about the overall implications of making all these decisions and how it's going to affect the overall system. That's the thing that makes it very, very hard. The other thing is that when I add extra nodes, they explode, and I think that the reason why is because it depends on the structure of the graph, the way that and this is a problem because the way that the joint works. So yeah, I have to see. This is the reason why I was also logging here, I think, the anchor, because I have to see if I can change the properties of this joint here on the simulation, because depending on what kind of graph it is, it's kind of like a network X or VJS, which is Let me see if I can find the example. Yeah, this example here. So, like, depending on what kind of graph it is, they are not going to reach an equilibrium because the nodes are just going to be too close, and because the nature of the joints is going to restrict the movement, but the nodes are too close, and then for some reason it becomes unstable, and then obviously that's bad because then you can't do anything with the graph. And this happens a lot with VGS as well, but then what you can do is just change these properties here, the spring length and the gravity and things like that, and it changes the graph, and then it allows you to see. So this is the stuff that I'm trying to achieve as well, but obviously in order to achieve that, I think I'm gonna have to be able to change the properties of the graph programmatically, or the joints. So this is exactly what I'm trying to do, actually. I'm just trying to achieve the stuff that they did on VGS and then build on top of that. And the reason why I'm not using VGS is because it doesn't work with WebGL, so it's less efficient, and I think also Rapier is a lot faster because it uses WebAssembly. So I think that for some simulations there are going to be hundreds of thousands of nodes or millions of nodes, so I can't really use VGS, I think.
Same as acceleration, and the position, which is y in this case, changes by the velocity. That's all I need. Change y by velocity, change velocity by force. The only thing is I need a velocity variable, and I need it to start at 0. Oh boy, okay, interesting. I'm getting something. It's springy for sure, but I think the issue here is my value of k is much too high. So let's use a lower value. And we can see there it is, springing back and forth. Look at that spring. Oh, it's so springy. So let me add a little damping in here, and just say velocity times equals 0.99. Meaning it's going to lose 1.
I think for now, I'm just going to put random k here. That's the same thing that he did there. I was gonna put a comment here, but I think it's kind of self-explanatory. Maybe I should just put distance and then. Yeah, so I think here I should call the spring forces. Maybe after I create the joints better. Maybe I should initialize this here as well. Makes more sense.
Percent of its velocity every time.
I think I'm gonna go back because but I think he's not gonna talk about this rest length there. I'm glad he made this video. It's very good. I don't like his style that much. It's not for me, but this video is very useful. But I think it's also because I don't like his style and from other people because they're too slow, but I think it's because I'm getting used to listening at everything at 2x speed, so normal speed becomes kind of boring. So, and this other thing that I was thinking about the other day as well, that's I wonder how fast you can train yourself to listen to. It's kind of like listening to another language. That at first it feels really weird, but I think that you can train because it's just sound waves. So I think it might be possible to increase the speed over time. I think I'll be right back.
Every frame. And that's kind of like how you might imagine maybe there's some air resistance or some other kind of force that slows the spring down over time and eventually it comes back to at rest. All right, so you can pause this video now and maybe try some interesting things, have more than one spring, because you kind of move it up and down with the mouse, because you have to go left and right, but really there's not a lot that I can do with this without adding in the idea of a vector. So let me redraw this diagram with it at an angle so that we can bring in the concept of vectors here. I mean, the concept of vectors could have existed with my previous diagram, it's just I think it would be illustrated better if it's at an angle. Now, if vectors are unfamiliar to you, again, I can refer you back to that whole video series about vectors, but the idea of a vector in one sentence is an entity with magnitude and direction. And so I could draw it in this diagram here as an arrow. This could be the spring force. It has two elements to it. It has its direction, which way is it pointing? Back towards the bob, or towards the anchor, I suppose, and it has a magnitude. How strong is it? What is its length? This formula still gives me the magnitude. The force of the spring, the magnitude, the length of this vector is negative k, the spring constant, times x, the displacement. The issue is I need to figure out the direction. And the way that I can figure out the direction is if I know the anchor point, if I know this as position A, and I know where the bob is, currently down here, if I call this position B, I can create a vector that points from A all the way to B by taking B minus A. If we think of vectors having two components, an x component and a y component, I just need to subtract b's x minus y, b's x minus a's x to get this value, b's y minus a's y, it was very awkward to say, to get this value, b minus a. Whew. So coming back to the code, and let me create a new version of this. Instead of y, I want to have position, or maybe I'll call it bob. And let's also have a vector that keeps track of the position of the anchor. So you can see the create vector function creates the vector, and it's really just storing in x and y. 300 for x, 200 for y, 300 for x, 0 for y. Let's draw both of them. I'm going to comment this stuff out. And we can see I have two vectors, one for the bob position, one for the anchor position. Now, I need to get a vector that points from the anchor to the bob. Now, this might look like a totally insane line of code to you. It would be much nicer if I could just write bob minus anchor. I have to use the specific vector functions. This one is for subtract. I can make a vector from subtracting bob minus anchor. Again, all this stuff is covered quite more extensively in my vector videos. But for now, we just realize that inside that variable v is a vector that points from here all the way to there. A vector that is exclusively noting the direction is what's known as a unit vector of length 1. So I can call this function normalize to take that vector and normalize it to a unit length 1. In a way, I can sort of add it to this formula here. V with a hat on it. This means the unit vector, this is the direction. So I have a unit vector pointing in this direction. I just need to multiply it by the spring constant, the displacement, and then reverse its direction to -1 to go this way. V dot multiply times k, V dot multiply -1, and then V dot multiply by the displacement. How do I get the displacement? Aha, guess what? Remember when I got this vector that pointed all the way from A to B? The magnitude of that vector, the length of that vector is the distance between those 2 points. Perfect. So before I normalize it, let's say let x equals V dot mag. And obviously, I'm being silly by having these 3 lines of code. I can multiply by -1 times k times x. That is now the spring force. And I think I'd rather rename this variable now to force. And I've done essentially exactly what's in these 2 lines of code, but now with a vector. Now, I just need to adjust these 2 lines of code to work with vectors. I need to have velocity has to be a vector. Oh, so this has to be a vector. And force is already a vector, so I can change this to adding the force to velocity. That's the vector way of adding. And then bob dot add.
Yeah, that's the issue here, is that he is using vectors. I'm not sure. Probably the thing has vectors as well. the Rapier JS. Yeah, vector too. I think if you multiply it, it's gonna be a scalar. Obviously, I think the multiplication of vectors is a scalar. So, but it looks like this doesn't have methods, which is the problem. Because I don't want to think about how to implement the multiplication for any case. It's gonna be like obviously the like multiply one row with the other column. So yeah, if you multiply a vector by a matrix, maybe two different vectors is just the same thing every time. So I think I'm thinking about whether or not it's worth to think about this stuff, or I should just do it like manual way to get the points and multiply. I think I need to go back a little bit to see what is the anchor. Because it doesn't make a lot of sense for the force should be just the differences in positions, I think.
And let's also have a vector that keeps track of the position of the anchor. So you can see the create vector function creates the vector, and it's really just storing in x and y. 300 for x, 200 for y, 300 for x, 0 for y. Force of the spring, the magnitude, the length of this vector is negative k, the spring constant, times x, the displacement. The issue is I need to figure out the direction. And the way that I can figure out the direction is if I know the anchor point, if I know this as position A, and I know where the bob is, currently down here, if I call this position B, I can create a vector that points from A all the way to B by taking B minus A. If we think of a vector as having two components, an x component and a y component, I just need to subtract b's x minus y, b's x minus a's x to get this value, b's y minus a's y, it was very awkward to say, to get this value, b minus a.
Oh yeah, so obviously it's going to be the distance times k.
Back to the code, and let me create a new version of this. Instead of y, I want to have position, or maybe I'll call it bob. And let's also have a vector that keeps track of the position of the anchor. So you can see the create vector function creates the vector, and it's really just storing in x and y. 300 for x, 200 for y, 300 for x, 0 for y. Let's draw both of them. I'm going to comment this stuff out. And we can see I have two vectors, one for the bob position, one for the anchor position. Now, I need to get a vector that points from the anchor to the bob. Now, this might look like a totally insane line of code to you. It would be much nicer if I could just write bob minus anchor. I have to use the specific vector functions. This one is for subtract. I can make a vector from subtracting bob minus anchor. Again, all this stuff is covered quite more extensively in my vector videos. But for now, we just realize that inside that variable v is a vector that points from here all the way to there. A vector that is exclusively noting the direction is what's known as a unit vector of length 1. So I can call this function normalize to take that vector and normalize it to a unit length 1. In a way, I can sort of add it to this formula here. V with a hat on it. This means the unit vector, this is the direction. So I have a unit vector pointing in this direction. I just need to multiply it by the spring constant, the displacement, and then reverse its direction to -1 to go this way. V dot multiply times k, v dot multiply -1, and then v dot multiply by the...
Let me think about. I don't understand why he did things this way, because why not get the distance and then multiply directly? Why get the unit vector and then multiply by k and then by x? So maybe I'm missing something.
the displacement. How do I get the displacement? Aha, guess what? Remember when I got this vector that pointed all the way from A to B? The magnitude of that vector, the length of that vector, is the distance between those 2 points. Perfect. So before I normalize it, let's say let x equals v dot mag. And obviously, I'm being silly by having these 3 lines of code. I can multiply it by -1 times k times x. That is now the spring force. And I think I'd rather rename this variable now to force. And I've done essentially exactly what's in these 2 lines of code, but now with a vector. Now, I just need to adjust these 2 lines of code to work with vectors. I need to have velocity have to be a vector. Oh, so this has to be a vector. And force is already a vector, so I can change this to adding the force to velocity. That's the vector way of adding. And then Bob.add velocity, and then velocity multiplied by 0.99. So again, I'm doing everything exactly as before. I just
So he's getting the force of the... He's getting the magnitudes, so I think the magnitude is gonna make it so that it's always positive. But maybe not. I think I'm just gonna use this one. It's pretty much the same thing that he's gonna do, but it's more simple. Yeah, but I'm gonna remove this thing here. Because it's always gonna be part of the physics, all of the nodes, I think. The only thing that I don't understand about this is this distance here. They pass on the VJS code. They pass as half of the edge length. If there is no distance, if you don't put the distance on the options or something like that. But I don't understand why. Maybe it's just part of the formula for calculating. Yeah, maybe it's because like it's the midway point between the two, but it has something to do with that. And obviously here is gonna be k, so I guess this should pass as an argument. I'm probably gonna use options as well to pass. I was thinking about this as well. Because there's gonna be a bunch of different arguments, so it's better to pass as an object. And then call it options, and then to customize the graph later. So I think I'm gonna pass this as an argument as well. And in this thing, I also don't understand. Why is max here? I'm just gonna remove it. And obviously here is gonna be the body, so. Let me. I have to go back, just see if I'll just go back and then go forward again. Yeah, so this is node 1 and then node 2, but I don't understand why this one is, it has this comment here. Another case where one node is not part of the physics. Doesn't make a lot of sense for me. Maybe it's because when you put the force here, it's gonna act on the other one. Because they're connected. So if you put on both of them, then it messes up the thing. Because obviously then it's just at equilibrium, I think. I think I'm just gonna comment this out and then I will just test to see what happens. Maybe the condition is not useful. Yeah, the problem here is gonna be that if I pass the edge length is gonna, if I pass it as the distance, then obviously it's gonna be 0 there. So the force is gonna be 0. So I guess I'll just translate or just remove this equation from here because it's the same equation that they have here. And then I just put this as 0.5 as the distance, or the edge length as double the distance. Or I just remove, obviously, because it's double. I just put distance there. Distance times k divided by distance. I think that's what I'm gonna do. It doesn't matter that much. You can change this stuff in the future, I think. To just remove edge length from here. But the thing is, I think I'm gonna have to put this stuff inside of the. I'm gonna have to create another function, or maybe I just use this one and put inside of the loop here on the tick. Because if I just put here, it's just gonna initialize like this, but then I'm not really sure if by initializing it's gonna update automatically based on the step of the engine. Maybe it does. And then I'm probably gonna have to initialize the stuff with a damping thing there. This stuff here. So something is wrong. Oh, I didn't pass the right thing here, I think. Let's just pass 0.01. And then remove this from here. But I think there's something wrong as well. And the thing is, I think I need to add the event listeners first to the nodes. But it looks like it's kind of working. But it's hard to tell. I guess what I can do is just put a very large number here and then see. It's gonna happen. It doesn't look like it changes anything. Oh, it's because I'm not. Yeah, I have to add the force. I can't just change the position. So let me see here. So I'm gonna have to use this vector. Oh, actually, like this. I have a feeling that it's not gonna work. Hopefully it does. Interesting. So maybe it did work. Hmm. Oh, here is translation, I think. I have to call translation. It's better if I wonder if I destruct is gonna. I think I'm just gonna leave it like this because it's gonna give me a problem because I'm using the reference of the object. So it's gonna be undefined if I destruct the things to get X and Y. And this is inefficient because obviously I'm calling a bunch of times, but this is not exploding now. Let's see if I increase the decay. So, but at least I know that the function is working. So, if it wasn't, then it wouldn't have any effect if I add it. So let me think about it. Blah, blah, blah. I think I'm just gonna watch the rest of the video. Okay, it works. Because it's a good video. But then I'm gonna leave it like this for now, and then I'm just gonna work on the events. I think if you leave anything more than one, it's too much. And the thing is that maybe if I add the damping thing, because right now it only has the force, and yeah, it's pushing away. So it doesn't have anything to. Maybe I should put the force on the other one, or maybe this should be. Let's see if I put a positive instead of making a negative, and it's just gonna attract everything. Yeah. So I think I need to put another force on the other one. To so one is pulling away, one is not sure pushing or pulling, but yeah. No, I'm not sure if that's what adds the effect though. Let me think. It still looks weird for some reason. I think it's just because like he shows on the video how to make it so that the lines are not straight. You just add a bunch of different points, balls inside of the lines, but you don't show the balls. But obviously that I think that's not going to be efficient. But yeah, this is the thing here, is because these ones are like they can curve, and these ones they're always straight lines, so it doesn't feel like it is a spring. It feels more like it is like a piece of metal or something. I don't like that. So I have to think about how to implement this. Maybe it's worth it to look at the source code for VJS. But it might be a waste of time. So I think like they use the vis dataset, which is another class, and I think I couldn't find a class last time, so maybe it's not possible to see the spring, how they make the spring. But maybe something here. And so I remember this stuff from CSS, which are the curves that determine the how fast or slow something goes. So I think they are using these Bezier curves. I'm just gonna look into this now, and maybe I think yeah, I'm gonna cut the camera and I'm gonna watch the video here as I eat something, and then after that I'm gonna study the class. I think study the JS codes, just see. So now at least I know that the force is working. I think maybe I should add the force, another force on the other node, but maybe that's not correct because then. But here on the video, I think he does that. He adds the positive force on one node and negative force on the other node. So maybe we should do that. But what I want to achieve is this effect here where it feels more like a spring because they can curve, the lines curve. So, and maybe I'll have to, maybe it's better to add the event listers first to work on that, but I think that's going to be annoying as well. Because for that, I'm going to have to think about whether or not I should, like how I'm going to structure the event listeners. And this is entangled with whether or not to use functions here or classes, because what I'm thinking about is just obviously creating another file and then allowing that file to manage all the event listeners, and then calling that function inside of this function, but then you might have implications. And I'm going to remove this file eventually because I'm not going to have the player there. But I have to think about this other stuff. So yeah, I'm leaving here for now because it's better to figure out the other stuff. So and here I'm pretty much passing the wrapper, which is the div that contains the stage in the main thing here. This is div here. To add the event listeners to that. And then as far as I understand, he is changing the value of this here, and this function runs every time on the loop. So whenever there's an event, changes the value of this, and then it does these calculations here to change the ball. So I'm probably going to use the same stuff to move the nodes. just change the events. And yeah, it should be easy actually, now that I think about it. The only confusing part is the whole thing about mixing events from the canvas and the elements. So yeah, I'll be right back.
I made a mistake. Okay, hold on. Let me finish my thought. I basically just changed everything, but one of the things about working with P5 vector is you can't use plus, minus, multiply, the traditional operators. I've got to use the mathematical functions. Velocity.add, velocity.multiply, et cetera, et cetera. So, but I forgot something. I forgot about the rest length. Right? We still have this rest length of 200. X is not just the raw magnitude of this particular vector. It's this particular vector minus the rest length. It's this displacement. So I should say x equals force.mag minus rest length. And, oh, well, I should move the bob down 50 pixels, and we can see it's springing. I should probably draw a line just to like have that line in there. And slowly, but I think I prefer having the line before the circle. And there we go. We've got our nice spring. Let's see what happens if I take the spring and move it off to the side. If I've done everything right with vectors, I should be able to position that spring anywhere, and it will move in the same fashion. Okay, so let's give it a start of 350 times 250. And there you go. Now you might be sort of wondering, like, that's weird. It feels like it should be sort of falling down or coming around to the center. Well, maybe if there were gravity, but this is just a totally made-up thing. So this is just, it's almost more like a top-down view where I'm looking at a table, maybe where you're pulling something out and springing back and forth. But it is interesting to think about, what if I do add gravity here? And yes, this is an oversimplification because I'm not thinking about mass and all sorts of other factors, but I could just make gravity a vector that points down, and then I could also add that force to the velocity. And now you see, it's kind of, interestingly enough, acting like a pendulum. Let's move it all the way over to the side and see what happens. And it's kind of awkward and weird, but we've got a springy pendulum swinging back and forth. Maybe that gravity should be a lot stronger. Maybe I should be thinking about math. I'll leave you to play with all of that. And just to add one more thing to this, I think it would make sense for me to be able to move the bob around with the mouse, and I could do this in a much more elegant way. But I'm just going to say if mouse is pressed, I'm going to set the bob's position to the mouse location, and then also I'm going to set the velocity to 0 because I'm locking it in place. It's no longer moving. So I can click the mouse and I can move it anywhere I want. So if I move it over here, it should spring back up. And then if I click the mouse again, I can move it here, and it'll spring back down. So that's just one thing for you so you can sort of play with it. Again, awkward interaction. I encourage you to see what kinds of things you can add to this to make it feel a little bit more elegant and visualize it in a different way. But I'm not done yet. I have barely scratched the surface of what's possible to do with springs. And in order to get further with this, I need to expand my thinking beyond the idea of just there's one anchor, there's one bob, there's one spring. I should really not even be distinguishing between the idea of an anchor and a bob. Really what I want to have are particles and springs. Let's say I have a bunch of particles like this, and each one is connected with a spring. I pull one, it pulls the other, which pulls the other, which pulls the other. I can start to create simulations of soft bodies. I can even make a square, attach the edges with springs, put some cross-hatching in it with springs, and I've kind of almost got a skeleton of a squishy, spongy body. Now ultimately, I have video tutorials that show a lot more about how to do this with physics libraries like toxic lids. And you can go explore those. You don't need to code your own spring forces, but I'm just going to go with it. What I want to do is create a particle class, which would represent any one of these dots, and then a spring class, which would represent any one of these lines, and have the spring class be responsible for the spring force calculation and see what happens. Now, as much as I might like just to sit here and type out all the code for a particle class, I've done this in so many videos before, and it's outlined in chapter 4 of the nature of code. So I'm going to go over to that example that I have on GitHub, which has an entire particle class, and I'm going to bring that into my code. I'll talk through what the pieces are in there, but rather than type it all the way through. I'm going to make a new file called particle.js, reference it in index.html, and then paste in that code. Now, there's a few things that I don't need. For example, I don't need this idea of lifespan because I'm not going to have particles that fade away in this example, though you could conceivably have that. I'm going to get rid of this run function because I want to just use update and display separately. I like to call this show these days, so I'll change the show. No real reason. And also don't need this is dead function because, again, the particles are going to live forever. It's a wonderful place where particles live forever. So what is this particle? It's an object that has a position, a velocity, and acceleration. It happens to have a mass, although the mass is just one. It has an apply force function, which takes any given force, applies it to the acceleration, and has an update method, which once again, I can get rid of this lifespan, add the acceleration to the velocity, add the velocity to the position, and then it has a show function, which draws it. Going to the sketch, I want Bob and Anchor to be particles now. So I want to say Bob is a new particle, Anchor is a new particle. And I'm passing them the xy position of where they begin. So just checking the particle system class. I did this in a slightly different way. So let's give the constructor arguments xy and say create vector xy. I guess this particle also is initialized with a random velocity, but I don't want that. So create vector 0, 0, 0. Now I should be able to get rid of velocity from here because velocity is part of the particle itself. Gravity you can still consider part of the world, so that could be a global variable out in the main sketch area, but I'll worry about that later. Ultimately, let me get rid of circle, these two calls to circle, and all the fill and the stroke, and I just want to say Bob.show, Anchor.show. Get rid of this, and I'll comment all this out. Great, so there are the Bob and the Anchor. Let's move the Bob down a little bit, and also, and this is all a little bit silly, but I'm going to make them a little bit bigger. I can get the nice blue color I had before, and there we go. So what's next? I want to take the idea of a spring, right, which is here, rest length k is the idea of being connected between the Bob and the Anchor. I want to package that all up into a spring object. For example, I ultimately, like, velocity shouldn't be here. I just need one more variable, I need to call it spring, and these would not be separate variables anymore. I would then just say spring equals a new spring, and maybe it has a value of k of 0.1, it has a rest length of 200, and it connects the Bob and the Anchor. Right? These are all the pieces of data that I need for a spring. What is it connected between? What is k, and what is the rest length? Clearly, I need another JavaScript file to put my spring class. Let me fill out the basic skeletal structure of the class. What are the elements that I need? A value of k, a rest length, and 2 particles. These can all be arguments of the constructor. Then, when it's time to update the spring, what do? Hooke's law. This is where that should go. The idea of updating the spring is calculating the spring force and applying it to those 2 particles. So all of this code that I worked out before can go right in there. Now, I changed the name of some things. So the force, I'm subtracting a from b now inside this generic spring class. The rest length is a property, so I need this dot. And k is a property, so I need this dot. And then I need to apply those forces. However, there's a little bit of an issue here, right? If the force is being applied to both particles, the force, if this is the spring, and I were to extend it, the force for this particle would point inward, and the force for this particle would also point inward, pointing in opposite directions. So let's take out the -1 here, apply it to this particle, then multiply by -1 to reverse its direction, and apply it to the next particle. I might have gotten which one to be -1. I can think about it and probably get it right, but we're just going to keep going. I also want to draw the spring. I'm going to say stroke, wait for. So this became a little bit convoluted. I almost just typed this .a.x, this .b.x, but I forgot the actual x value is inside of a position vector inside of the particle A. So I've got to draw a line between A's position x, A's position y, B's position x, B's position y. So let's go back to sketch and try adding in a spring.show. Now we see that line, and this is very silly, but I only have these after that. Okay, so now we see them connected, and I don't know, I should play a drum roll or something. If I just type spring.update, is that force going to be applied and it's going to work? I'm going to type it very slowly. My eyes closed. There's no chance this works. No, okay, got an error. Good. Well, you know, it wouldn't be a coding challenge if I didn't get any errors. There's an error as copy could not be called. v.1.copy is not a function. Spring line 11. All right, let's go back to spring line 11. Oh, look at that. So the mistake that I didn't make inside of line, I made up in update. I want to subtract B's position minus A's position, but not the particles themselves. I need to say A.position and B.position. Okay, good. I don't know. I don't have any errors, but I don't see anything moving. Oh, guess what? So I'm applying the spring force to the particles, but the particles I'm not calling the update method. The update method is once that spring force ends up in the acceleration, it updates the velocity and updates the position. So that is something I also need to add. Bob.update, Anchor.update, Spring.update. Whoa. Okay, I think maybe I had the directions wrong. So most likely it's the other way around. If I go back into the spring, this makes sense. I want to take the one without the -1 and apply it to B, and the one with -1 and apply it to A. No? Oh yeah, whoa. This is kind of interesting. Something's wrong here. Oh, look at this. There's just like a literal typo. I said this position. I don't know what it's getting there. There we go. That's what it should have been all along. And actually, I had it right in my head, but I should have said B minus A, and then this would be then this would be A, and this would be B. There we go. Now, there's no other forces in the system. There's no friction or drag force in the system. So I might here in the particles function, if I wanted to optionally, I could include that back. And over time, you can see it would eventually spring to kind of being at rest. Let's add back in the mouse control. So now you can see as I drag this around, I'm kind of pulling this thing that's kind of attached to me by a spring, and I can kind of swing it around and do all sorts of fun physicsy things with it. But I'm still missing those sort of wonderful possibilities of creating an entirely interconnected system. So I know there's just so many different directions this can go in, and I really want you to try and experiment on your own, but I'll just give you a little bit of a starting point. Let's create a line of springs. So first, let me give myself a lot more vertical space to play with. And instead of a separate Bob and Anchor and a single spring, let me make 2 arrays. And let's sort of create, let's space out particles by an arbitrary number. I'm going to say 50 pixels. And I'm going to create 5 particles. And instead of showing updating each individual one, let me do that in a loop. Great, there's all my particles. Let's space them out a little bit more. I also want to make them kind of smaller. And now I need to connect each one with a spring. How do I do that? Looking at this, I can see that the second particle should be connected to the first. I mean, index 0, index 1, so index 1 should be connected to index 0, index 2, index 1. So as long as I'm not in this loop in the 0 element, as long as I'm not in the first particle, then A is particles index I, and B is particles index I minus 1, the previous one. And so the spring that I want to have is a new spring. Maybe the rest length is spacing. What was the order of the things in the constructor? K rest length AB. Let me make a global variable K. I was going to all individual Ks, but I'm not going to worry about that. K, spacing, particle A, particle B. And then let me add that to the array of springs. So this is a way of saying every particle connected to the previous one in the array. Then I want to update and show all the springs. So far, so good. How do I know if this is really working, right? Everything's at rest, so nothing's moving. Well, what if I were to say, at the bottom, I'll consider like the tail, meaning the last one. I'm going to say let tail equals particles, index the length minus 1, which is the last one. And if the mouse is pressed, set the tail's position and the tail's velocity. There we go. Look at them all squishy squashy with each other. That is awesome. And I can do things like make the spacing 20 and have 20 of them. And I can start to pull them like this. I could also consider having an option in the particle class itself to have a Boolean variable called lock. Basically, if this particle, I'll call it locked. If this particle is locked, or if it's not locked, update all the physics. So basically, if a particle is locked, no physics, it can't move, it can't do anything. Then I could say in the main sketch, after I make all the particles, particles index 0 locked equals true. So that first particle will always be locked to the top. Now, I've made, oh, is the rest length still like 200? No. I wonder if I want to make, I'm just curious, like this is very squishy. Like what if, I guess maybe if I increase the actual K value. Yeah, this is sort of more what I might have imagined. But also now I could add back in some gravity to make it feel like it's a thing that's hanging. So let's actually add back into gravity. Basically, I'm also going to say P apply force gravity. So take that gravity force that I created, and you can see, oh, it's pulling them down. So that makes sense, right? It would always pull it down slightly. I almost don't want to see the particles, so I'm going to take out the showing the particles. So I just have this string, and I can kind of like move it around. Let's give myself a lot more space to work with. Set it in the middle, and go back to 50, and just have like 5. And we can see all the kinds of different behaviors I get. So there's a lot of parameters of the system that could be played with. A place where we might start is just change the way this is being drawn. You know, am I drawing the particles? Am I drawing the springs? Which things? How am I drawing them? How am I connecting them? For example, what if I use begin shape and end shape instead of with the positions of all the particles to connect them with vertices? Let's see. Look at this, it's actually a closed shape, so it's almost as if I have this piece of cloth that I'm kind of like swinging around. And incidentally, I could use curve vertex. And now it's going to look much more sort of curvy along the side. Now, strangely enough, it looks like where's the top point and the bottom point? One of the things about curves, and this is a bit of an aside here, but curves need an entry point into the curve defined and an exit point out of the curve defined. One quick thing that I could do is just, I already have this tail. What I'm just going to do, I could just say, let's add an additional vertex for the tail, and then also for the head. So I'm just doubling up on the first and last point. And now we can see, and I kind of want to, I love this idea of this cloth, but ultimately, let's just see what happens if I say no fill. You can see this feels much more like this sort of soft string that I am curling around. All right, so I really hope that you kind of enjoyed this long process of starting with just like a single variable, moving to vectors, and then moving to objects. If you create something from this, please look in the video description. There's a link to the Coding Train website where there is a webpage that you can share a link to your own creation. I think there's a lot of possibilities here, whether you explore the way this is visualized, whether you explore how you are mapping out your whole structure. Can you make like a little squishy robot character out of a head and a body and some legs? There's a lot of things you could do here. Of course, I should also note that this is a common enough technique that there are many other physics libraries that you could use that have particles and springs built into them. Box2D, Matter.js, Toxic Libs, and I do have other videos that cover those. There's something, and a lot of them have more robust and accurate techniques in terms of how the actual physics is calculated. So I encourage you to explore those. I'll leave links in the video description for you to explore those. But there's something nice about having it right here in your code. This will integrate into any 5JS sketch that you already have. If you've been working through the nature of coding and have sketches with different forces in them, spring forces will just add right in seamlessly because this is set up in the way that all those examples are set up. So there's a lot of possibilities here. Thank you so much for staying all the way to the end of this video, and I'll see you next time on the Coding Train. Goodbye!
So it's just too hot to be programming indoors today, so I've come outside into my garden. Anyway, in this video we're going to be looking at something that's become so ubiquitous you probably don't even realise that it's there. We're going to be looking at panning and zooming. To demonstrate panning and zooming, I've created a small application in the console game engine, and it displays a grid at different spatial scales. I can use my middle mouse button to pick up the grid and move it around relative to where I've positioned the mouse cursor. And this is quite important, because it doesn't matter where I select the cursor location, the grid moves relative to where the cursor is on the screen. And this gives the really compelling effect that I have indeed picked up the screen space, and I'm moving it around with my hand. It's a very tactile user interface tactic. I've also added the facility to zoom in and out, and we can see here, now the grid zooms a little bit strangely because of the very low resolution I'm using in this application, so you see the cells aren't quite the same size, but that's irrelevant here. What we do see is that the grid grows and shrinks. But most importantly, it depends where the mouse cursor is as to where the focus of the zoom point is. You can see I went to the top left there and I'm moving back out, and if I go somewhere down here in the middle, just move the cursor as you can see on the video, and it's always ensured that the point you're zooming into remains in the same location. This is to avoid the user getting lost. It also doesn't matter how far zoomed in we are when we start doing pan operations, the same strategy still applies. And in fact, once you have established a suitable strategy for world space to screen space transformation, we can do everything through that transformation, so I can even select cells in the grid by clicking on them, and it doesn't really matter what the spatial scale or position of the grid is. And I can also move the mouse cursor whilst I'm zooming too. Get a slight rotation effect there. So let's have a quick look at what's going on, and we'll start with the easier one, panning. We've actually done panning several times before in previous videos. For example, the RPG series as the screen panned around, and the Jario platform game series. And both of those relied on a simple concept that we have a screen space where our top left is 0, 0, and we have some world space that represents the space we want to draw on the screen. I'll just draw that in green here. And the reason I'm drawing it off-center like this is to make a point, but we can assume that the world space had a one-to-one relationship with the screen. So top left of the world space was up here, and we also knew that to be 0, 0. However, to pan this around, we needed to store two offsets, one which was here, which was offset x, and one here, offset y. And so if we take a point somewhere in world space, let's say in this instance it's 10, 5, and we wanted to draw that in the corresponding screen space, which let's say for argument's sake is about here, then the translation was quite simple. We simply subtract the offsets from world space to screen space. So we go in the x direction, and then again in the y direction. Therefore, without any scaling, we can get some very simple equations that the screen space x location is equal to the world x location minus some offset x. And of course, exactly the same goes for the y-axis. And we'll see this a lot. There's all these things happen to both axes simultaneously. And with some very simple algebra, we can work out the transformation between world space and screen space. So here, we've got world x equals screen x plus the offset. Simple stuff. We're going to be using these transformations so much that I really recommend that we have a world to screen function and a screen to world function. Let's start writing some code to see if we can implement panning. I'm going to start with an empty console game engine project, and this time I'm going to construct a console which is 160 characters wide by 100 characters high, and each character is 8 by 8 pixels, so it's reasonably low resolution. And in the onUseUpdate function, I'm going to draw a grid. Well, the first thing I'll do is clear the screen to black. If I want to draw a grid of 10 by 10 cells, I need to draw 11 vertical lines and 11 horizontal lines. I'll do this with a for loop, but this for loop, you may notice, goes to y is less than or equals 10, so this effectively gives us 11 iterations through the for loop. Each cell in my grid is going to be 1 unit across by 1 unit high. And because I want to keep this code as an example for others to easily follow and implement in their application, I'm going to be quite verbose with how I name the variables. And I'm leaving out a lot of optimizations. So for my line, I want to create a start point and an end point, designated by the sx and sy and ex and ey values here. And typically, what I would do is call the drawLine function to draw a line between these coordinates. However, we need to factor in our offset. So we'll come back to this in a little while. Somewhere in our system, we need to store the transformation variables. So I have two floating point values, f offset x and f offset y. I'll initialize those to 0 to begin with. And now I'll add my two transformation functions. So this is world to screen, and a corresponding screen to world. So let's look at the arguments. I'm going to pass in a coordinate in world space, x and y. These will be floating point, but I'm going to return via the arguments the corresponding screen space coordinate. And these are integers because our screen is discretized. Now we don't have any scaling at the moment, so what I'm going to do is just handle the panning. So we'll take our screen coordinate, and we'll need to cast that to an integer because the operation is going to be performed in floating point domain. And I'm just going to implement the equations that we saw before. If I can type. There we go. And of course, we don't want both of these to be x, we want one of these to be y. In the same way, let's handle the screen to world transformation. This time we'll need to cast to a float our end screen variables. Let's go back to where we were drawing the grid now. What we can see is that the coordinates here are in world space. Each one of my cells is 1 by 1. I'm going to need to convert these to screen space. So I'm going to create an additional 4 variables, which are the screen space equivalent of the world space variables. And then I'm going to call my world to screen function. Now, all draw routines will only occur in screen space, so it's important that we use only the new variables to do this. I'm going to draw the line as a solid white line. This code has handled 10 horizontal lines. Let's take the same code and repeat it. This isn't optimal. We could do everything in the same loop, but I'm trying to keep it as clear as possible, and we'll use this loop to draw 10 vertical lines. As you can see, the rest of the function remains unchanged. Let's take a look. Well, we see a rather boring white square at the top left of our screen. Well, that's kind of what we expect because this square is 10 by 10 pixels, because our grid was in unitary cell size, remember? And our offset is currently 0, so our world space is a direct mapping 1-to-1 of our screen space. In onUserCreate, I'm going to default our offset variables to point to the middle of the screen. So I'm going to take the screen width and screen height and divide it by 2. But I need to invert this number because the offset is negative. Because if we study our world to screen function, we're going to be subtracting this negative and adding it. Let's take a look now. So now we can see that the top left of our world space is mapped to the middle of our screen space. Let's push the drawing routines to the bottom of our onUserUpdate function. And given that this is going to be a heavily mouse-driven application, I'm going to capture the current mouse coordinates at the start of the routine. Of course, the mouse operates in screen space. So whenever the user clicks with the mouse, and draw a crude mouse cursor in here, we need world space to be transformed around where the mouse has selected, because we want world space to always remain relative to where the mouse has been pressed. And to do this, we need to store some additional offset information from the top left of our world space to the current mouse position in world space. So we need to store this offset too. I'm going to call this startPanX and startPanY. And I only want to update these variables when the user presses the mouse button. So I'll add an if statement that checks to see has my left mouse button been pressed. If it has, it captures the current screen space mouse coordinates and stores them in startPanX and startPanY. As the user drags the mouse, we want to update our offset positions to move the world around. So I'll respond to that on the beheld flag. As the user drags the mouse around the screen, the mouse coordinates may change, but the startPan position doesn't. Therefore, we want to set our offset by the difference between the mouse coordinate and the startPan coordinate. I also need to now update my startPan location, so in between frames, it's as if startPan has been clicked each time. I should point out that it doesn't matter if you're using an event-driven framework. The concept is exactly the same. You just respond to your on-click and on-left up and on-left down or appropriate events. So let's take a look. We've got our rectangle in the screen, and it doesn't matter where I select with the mouse cursor, the world is translated into the screen relative to my mouse cursor. So let's try a really odd one down here. There we go. And of course, let's try right in the middle of the rectangle. Very nice. And we should also handle something in the negative domain as well. So we know in our world space, the current screen cursor will be in negative world space. And that works just fine. Let's put that back in the middle for next time. And that's all there is to panning. It's pretty simple, isn't it? However, zooming is a little bit more complicated. Zooming requires that we somehow scale the world space as part of our world to screen and screen to world transforms. So I'm going to store two additional variables, scale x and scale y. And by default, I'm going to set them to 1. So that maintains our direct mapping between world and screen space. Now, to my shame, I have no mechanism for capturing the mouse wheel as part of the console game engine. I certainly will add that in the future. But typically, you would want to use the pressing of the mouse wheel as part of the panning operation, and the scrolling of the mouse wheel as part of the zooming operation. I'm going to emulate this with the Q and A keys being held down. So I want to zoom in, i.e. make things larger, when I hold down the Q key. And all I'm doing here is increasing the scale value by 0.1%. And on the contrary, if I want to zoom out, i.e. make things smaller, I need to decrease my scale value also by 1%. Different policies for changing the scale variables can be implemented here. In this instance, this is a very smooth scaling effect. You might want to scale in discrete steps. But the downside to this approach is it is effectively linear. So as you start to zoom in, you need to zoom in a lot more to see any difference on the screen space. But don't let that put you off trying this method. This gives a very nice feel in zoom. Now, as I've already mentioned, scaling is simply adding multiplication of the scaling value somewhere in our transform. And so when we're going from world to screen, once we've transformed the offset, we just want to multiply by our scale value. F scale x and F scale y. And if we do the algebra, that means in our screen to world transform, we want to divide by F scale x here and F scale y. If you're just starting out on your programming adventure, you always want to be careful when you see divides like this, because you might hit a divide by 0 error. However, we've ensured that that can't happen with the way that we're handling the zoom value. This can never be 0. Unless you're one of those people that would like to start arguing about the properties of floating point numbers. So let's take a look. Here's the grid, and if I press the Q key to zoom in, well, we see the grid sort of shoots off to the bottom right, and if I zoom out, it gets smaller and larger, so I'm confident that the scaling is actually working, but the position of where the scale is occurring around doesn't seem right. And that's because our scale is completely centered around 0, 0, and so the offset from world to screen space is also scaled. This isn't quite right. We can demonstrate this to be the case if I push our world space to be right up in the top left of our screen space. This will be approximate, and I choose to zoom in. We see it zooms in reasonably appropriately. but as soon as I start to pan things, it all starts to fall apart. It becomes very difficult for the user to use. Instead, I want the world space to scale around where the current mouse cursor is in world space. So here, the black line outlines my screen space, and the green line implements my world space before I have done a zoom. If I want to zoom around this location, so that's where my mouse cursor is, and I choose to zoom in, the effect that I want is that this point remains the same. Unfortunately, we already have the facilities to handle all of this, because if I know where my mouse coordinate is in world space before I zoom, it's here. After the scaling, my mouse coordinate has also been zoomed. And if we assume that scaling is happening around 0, 0, which it currently is, so my zoom has actually happened here. So my new mouse coordinate after the zoom is about here. Well, if I look at the difference between the pre-zoomed mouse coordinates and the post-zoomed mouse coordinates, I can create a vector, which I can use to offset the new world space, because this vector will be the same as the vector that we need to displace the world. So before we do any zooming, I'm going to capture the mouse position in world space. And this is very simply done because we have the screen to world function. After the zoom, I want to do the same thing. But don't forget, the scale has changed. So the internals of the screen to world function has also changed. And once I have the before zoom coordinate and the after zoom coordinate, I can subtract them and update the offset accordingly to displace the world around the mouse cursor. So let's take a look. Well, I'll start to zoom in now. Oh, it seems to be a bit jittery and all over the place. That said, it's not going completely out of control. It still doesn't feel quite right. Why might this be? Well, the answer lies here, and it's where we create the offset for the mouse. This currently only ever exists in screen space. We're not doing any scaling here. So I'm going to divide by our scale values too. And you might think, well, why was that necessary? Well, if you look at this, this is translating mouse coordinates differences into a world space offset. And so that's a screen to world transform, slightly different in this context. But we can see in our screen to world transform, we're also dividing by the scale value too. Let's try again. Well, it's still a bit jittery, but at least now the zooming is actually happening around the mouse cursor. And if I start to pan the scene, that works equally well too. So what's going on with this horrible jitter? And it doesn't take long for me to discover the problem. It's that I clearly don't know how to program at all. Here, I'm casting this floating point calculation to an integer before multiplying it by our scaling values. I've got brackets in the wrong place. I need to enclose all of this calculation. And now you can see the zoom is very smooth indeed. Schoolboy error there, never mind. Well, that was all quite embarrassing, but whenever you see sort of jittering like this, it's usually a solid indication that there is an integer to float or the other way around conversion not happening quite as you'd expect it to. Now that we have working panning and zooming, we can start to do other operations using our world to screen and screen to world transforms. So the first one might be to actually select something in world space. I'm going to add the two variables selected cell x and selected cell y, and at that location in world space I'm going to draw a red circle. So after I've drawn the grid, I'm going to transform the selected cell in world space to screen space. Don't forget my cells were 1 by 1, so if I want the circle to appear in the middle of the grid, I have to add 0.5 to it. In this instance, I also need to scale the radius of the circle, and I'm just going to use the x scaling factor to do this. Throughout this program, we've kept scale x and scale y independent, and this would allow later on to scale independently in those axes. If you've got a plotting program, for example, that might be quite a useful thing. But in this case, I know that my scale x and scale y always change as a pair, so I can take one of them. They always assume the same value. And now that I have my transformed circle coordinates, I can simply draw a circle in screen space. To work out which cell the user has selected, I need to take my mouse coordinate and translate it to world space. Now, I already have grabbing the mouse coordinates as the first thing that I do in my program, and I could probably get away with using that, but the most accurate mouse coordinate is now the mouse coordinate after any zooming has occurred. And so I'm going to set my selected cell coordinate based on my transformed mouse world coordinate after any zooming has occurred. I'm going to do this on a right click. Let's take a look. So I'll just zoom in a little bit here, and we can see in the top left we have a circle, crudely drawn again, low resolution, in the cell 0, 0. And if I right click somewhere else on the grid, we can see it's working quite nicely. And of course I can pick it up and pan it and still select, and it selects the right cells. It doesn't matter what the zoom level is either, the transformation is fine. You can imagine this having lots of applications in level editors, image editors, and I think all sorts of different 2D applications. That's why this is such a useful tool to have in your programming toolbox. There are also a number of other optimizations we can exploit now. Now that we have a mapping between world space and screen space, why draw parts of the world that you can't see? How can we clip it? Well, I could very simply create 4 variables which represent the left, top, right, and bottom of the world in screen space. And I use the screen to world function to take my top left coordinates and put them in world space. And I can do the same for the bottom right by using the size of the console. And I can use these values to decide what I draw to the screen or not. I mean, after all, why draw things that you can't see? So to demonstrate this, I'm going to keep a track of how many lines that I'm drawing with a lines drawn variable. If a line gets drawn, I'm going to increment that variable. And what we do for y, we'll also do for x. And because we've chosen a low resolution, means I can easily draw strings and we can read them at the same time. Let's take a look. So currently, all the lines of the grid are drawn. That's all 22 of them. But as we start to zoom in, we can see our lines drawn count is starting to decrease significantly. Let's get it down to just the 1. There we go. So we can optimize our rendering framework very nicely. In fact, you could take this further. At the moment, it's still testing all of the lines. That's not necessary either. Why not only start drawing from a location which you know can be seen? You don't even need to do the test at all then. And finally, and very much just for showing off, I'll let you study this on your own time, we can also plot a graph. So let's make a lambda function which always returns the sine f function. The reason I'm doing this is we can easily change the nature of this function and explore it in different ways. Now this looks a little complicated, but I'll try and explain what's going on. I'm going to scroll across my entire screen, so I'm looking for all of the visible pixels from left to right in world space. And in order to do that, I need to know what my world space per screen pixel is, because I don't want to draw things unnecessarily, but I want to draw things at high resolution as we zoom in. So calculating this screen width per pixel is not that difficult. I just take the world right and world left values that I calculated earlier and divide it by the screen width. That tells me how much world space is attributed to each pixel. I'm going to store 4 integer coordinates, which are my pixels to be drawn, which is the current pixel and the previous pixel, because I don't want gaps in my function either. I wanted to draw a line between successive values. And this line here is just the very first value to draw, so it doesn't draw from 0, 0 each time on the function, it draws on the first visible valid location along the x-axis on the screen. So I'm going to loop from the left-hand side of the screen in world space to the right-hand side of the screen in world space, that's my x-axis. And for each valid location, I'm going to calculate the function. In this case, it's up here, in this lambda function, it's sine. And I'm going to offset it accordingly in world space. So my grid is effectively 10 by 10, I want to locate it to the middle of the grid. And don't forget, when we're rendering on a computer screen, positive y tends to be going down the screen. This is contradictory to mathematics as we know it, so I'm going to throw in a minus sign, so the sine function is the right way up. For each world space pixel, I'm going to calculate the screen space equivalent, and I'm going to draw a line. So let's take a look. And we can see here, we've got something that looks crudely like a sine wave, but I need to zoom in. But it draws from the left to the right of the screen at all times. The nice thing is it doesn't draw beyond those locations. And I can zoom in, and zoom in, and zoom in, and the function never loses any accuracy. And I can also pan. So a little bit of a rush at the end there, but it shows you just how sophisticated having these very simple transforms can be. And so that's that, a very simple yet powerful programming tool to add to your programmer's toolbox. If you've enjoyed this video, give me a big thumbs up, have a think about subscribing. All of this source code is available on GitHub to download and play with. You should come along to the Discord server and have a chat. It's growing every day. And take care, I'll see you next time. Hello, it's just too hot to be programming indoors today, so I've come outside into my garden.
I don't really understand that well, the video. How can I translate this stuff on the Pixie.js? It's gonna be very hard to do that. I'm gonna focus more on this spring now. I think the way that he implemented here is not very good, because it doesn't seem like it is very efficient. So what I'm gonna do is just study this code here and see if I can implement these functions on my own thing. Right back. This one here I don't understand. I don't understand why they... Well, I guess this function comes from the class, so it makes sense. I think I get it now. So they initialize the classes depending on the type of the edge that's gonna be, and then each class is gonna have this function here. I was gonna say that I don't understand why, how they draw a simple line, but now I get it. It's because I didn't realize that this is from the node there. So I think is hopefully more simple than I thought it would be. All I have to do is copy the classes, or like try to copy as much as possible, and then just call these functions and draw the line with these functions. The thing is that maybe I should do the same thing for the physics here, spend more time trying to understand the VJS. Since I already spent a bunch of time like reading all this code in the past, so it's gonna be easier now, I think. Like the main concern that I have with studying this stuff is that I don't want to spend a bunch of time not doing anything. And that's the problem. But I guess it feels like that way in the past, because it's just that there's a lot of stuff to study, so everything is very complicated, and so there's no way to... Because like definitely the feeling that I have up to this point is that it's taking too long to do the things, but I think I guess that this is like normal. It feels like I should be like doing things faster, but I think I can't really do it because it's very complicated. I have to understand everything first. That's probably fine. The thing that I'm thinking about is like if the drawing of the edges, I think an easy thing that I can do is just remove the amount of nodes here. I thought about this as well, because it doesn't make sense to put all of these nodes. It's gonna be a lot better to see. I have to see the... maybe after I draw the edges, I have to look into the event listeners. So let me write this down so I don't forget. This function here. The label I think is just based for the node, so... But maybe I should spend some time. I remember that the events are very confusing here though. On VJS. And the whole thing about the relative coordinates of each thing is very confusing as well. So I kinda hate thinking about that, because I'm gonna have to do the calculations to calculate the positions to change, I think, the canvas, but I'm not really sure if how to do that properly with Pixie, because it's gonna involve the shaders, the fragments, the buffers, like all the low level stuff that obviously the class handles for you, but then I have to understand what methods you call that are gonna change the matrices. This is the stuff that makes it very annoying. Maybe I should study the event system directly from Pixie and then just try to change based on the event system directly. I already have the functions on the viewport there. The thing that makes me think that maybe I should be going faster is because it looks so simple to do it, but maybe people take time. Not sure. Like, yeah, I guess like the best way to put it is that I'm concerned that right now I'm overcomplicated this. That's the thing. I guess that's my concern, because on the surface it seems very easy. Like, you just change, you find the scale property and then you change the scale. But then another thing is, like, every time you move the visualization is obviously going to move the position of everything. So the question is how to synchronize the physics engine with the thing, but maybe it synchronizes automatically. I'm not sure. I think probably not, because there's no way for the physics engine to know that the visualization changed and then the position of everything is going to change. So I think the only thing you have to do is just update the positions of everything on the physics engine, but that seems like it's very inefficient. So every time you pan or you zoom, you have to go over all the nodes that are on the scene and then or all the nodes on the physics simulation and then update them. It doesn't seem very good. That's why I think I'm like might be missing something. So I guess I have to, like, maybe it is better to spend a bunch of time studying VJS and trying to see how they do it, because they made, like, the way that their library works is exactly what I want. Is this effect here? That's exactly what I want, and I should be able to select everything. So I wanna get as close to this as possible, but obviously Pixie is more complicated because it uses the WebGL canvas, so everything's harder, I think. But I think that the issue is that the logic that they use is very hard to understand because of the way that they set up the events. So I couldn't find any way to see, which is what I'm planning to do later, to programmatically see how all the events are connected. But for now, I haven't found anything that allows you to do that, because that would make it a lot easier to understand. Because then I can just follow the events and see how they're gonna change the view of the canvas. That's the other thing, I guess, is because even if I see through VJS, it's gonna be different because the functions, but it's gonna be relatively the same, I think, but it might be very different actually because of the way that the visualization is done. But I think the relationship between I think I need to, it would be good to study VJS because it's gonna allow me to clarify the relationship between the physics engine and the events. How the events change the canvas and how is that gonna be connected with the physics. But I guess it's just gonna be through firing off an event after you change the visualization or before. And then the physics engine is gonna update. That's what I'm thinking about doing as well on my case there. So just figure out the relative coordinates, the boring stuff, annoying stuff. Then do the calculations to change the visualization, and then after or before you change the visualization, you call a function or something like that to update the physics engine. Just have to figure out what is the best way to do that. So I guess I'm going to study these classes now. The body contains, I think, the translation and the scale, if I remember correctly. Yeah, and it is more simple because it's not a matrix, it's just a normal canvas. So as far as I remember, and the body is initialized on the network, which is the main class. understand what this means necessarily. What is position based or not? Is the position of the node, that doesn't make sense. So it's halfway, like it's half of the position of the node. That doesn't make a lot of sense. Yeah, this is the problem with this understanding this library. And it's the same thing with Rapier JS, is these events here. It's very annoying to see. Like, how do I know the places that emit the events that are gonna trigger this function? And this function is just this one. It doesn't return anything. It just makes these properties of the class to update. That's the problem here. There isn't anything that... Oh, this is the property, but there isn't anything that makes it easier for me to understand how they make the edges be like curvy. Oh, maybe it's because it extends this one. I didn't see that, so maybe it's on this one. Let's see if there's anything here. Yeah, it doesn't seem like it has anything. Oh, maybe this one is interesting. Oh, so this is from the base class. So I think the base class is probably the one that is gonna allow me to understand, and then every other class is a variation of that. Let's go to the base class. Edge base. I guess it's very simple. You just get the position of the nodes, and then instead of drawing the line, you just create a Bezier line. Just use the function for whatever function they are using here. So here, instead of doing this, I create a line here. Probably. Like, instead of creating like this, from this point to this point, you pass to the function, maybe. This is kind of confusing to think about, but Yeah, I'm just realizing now. It might be, but I think I'm not gonna do this. But I think it's very smart what they are doing. So they're just doing one edge for several different nodes. The way that I'm doing now is like a unique edge between each node. But this way it makes a lot more sense, I think, because the forces are gonna be on the node anyway, so it doesn't matter. So you can just draw one edge, for example, that connects the whole graph. And because the forces are on the node, it's still gonna be... there's still gonna be the sensation that they're connected to each node separately. That makes a lot of sense. But I think it makes things more complicated to calculate, so I think I'm gonna leave the way that it is now, probably. Then later on, I think like after I solve all of the other main things to solve, then I'll go back to this. And this is an abstract method, so I guess yeah, abstract methods is when each class is going to implement its own version. So this is on the classes that inherit this one. And this is the binary search they are talking about. So the binary search is used to find the nodes in between the edge. So I think for my case, probably not going to use now. But maybe it's not that complicated to do that. The thing is, I still have... I was thinking like maybe if I know the first node and the last node, I only need the two, but I need all the nodes because it has to cross, the line has to cross through all of them. So Maybe I'm misunderstanding this thing here. I'm not really sure. Maybe just an arbitrary point between two different nodes. But that wouldn't make sense, because then why would you use binary search? Why not just get the middle or some random number? Oh, the arrows are gonna be annoying as well. What should do? But I think I'm gonna do it without arrows for a long time, I think. Because it's gonna be... Maybe it's not that difficult actually. Just a triangle, so... There's first point, then second, then third. And then it gets the distance. I don't know what this is supposed to be though. Px is obviously the... like, these are the two sides of the triangle. This is the... this is not the distance. I don't know. Is the squares that are the size of the sides of the triangle. So I guess this is from the third point to the first one times this one. Distance from the first to the second. Plus this. plus the y. I guess it's creating a smaller triangle and then dividing by this thing. Because it's... No, but it's multiplying, so it's a bigger triangle. Yeah, I don't know. I guess this is just a factor that is going to determine where the axis, where the point is. And then the distance is the x minus the final distance of where the third point is. As x is the total distance, maybe? Yeah, I don't know. I kind of understand, but not 100%, but it doesn't matter that much, I think. Thing is, I'm not really sure if this is necessary. But the thing is, I think the main thing is this. I need to clarify this thing here. Because I don't know if they are speaking about the nodes, about like the breaking points of the curve that they make. And if that's the case, then how do they select the breaking points? I guess it depends on each class, maybe. So maybe I was thinking that they use only one line to connect multiple different nodes. But now I'm thinking more about, so like for example, they are using like only this line here to connect all of this. And then because the node is on top of the line, it seems like they are connected by different lines. And then the via thing is this node here, and then it has to calculate the distance to this node, and then it's gonna do that. It's gonna draw the whole line based on these distances. But now I'm thinking more about that it is like this, and then they pick arbitrary points here in the middle of this line, or anywhere along this line, and then based on the points is the place where the line is gonna break down and do the curve. So if that's the case, then I think I need to figure this out to implement there. But if it isn't, then I think I can try to do the simpler way, more simple way. 0, 1, or 2 control points. Ah, interesting. So control points is the thing that I'm talking about, I think. Is the breaking points of the line. So maybe it's not the same thing. Maybe my intuition first of what the via is correct, but maybe not, because you're using via, sure. But this might be the two different nodes. No, it is via. So via is the breaking points, so it's not the nodes. I thought the reason why they might do it like this is because then it allows you to draw just one line instead of drawing the line multiple times for each node, but I think that's not what's happening now. I think the via nodes are just the breaking points in the line. So I do need to understand this stuff here. Oh, I think that I understand now. Oh, maybe not. I was gonna say like one way to do it is just to put different distances between them, like arbitrary distances, and then they draw multiple different lines. But then it wouldn't be good because like there would be no curvature, so doesn't make sense. So you can just call this stuff here. I don't want to spend a lot of time on this. I'm just gonna do whatever I think is the simplest thing, because there's so many other things to solve that I think are more important. But this is just a detail that I think is better because it looks nicer, but it doesn't matter that much, like, and I can figure out later. The events are more important, I think. So now what I'm thinking is, like, how can they see on the code when they call these functions? I need to find the first function that they call, just see what they are passing as via node. See if there's any calculation that I can copy. Because if there isn't, I can just put like 2 arbitrary points, like get the distance between them and then maybe divide by 2 or like whatever number I want, and then like to make it symmetrical, so that's, and then pass those 2 points. Another thing that I think I can do is just, I can cache somehow. Maybe I can return here in this function, return the distance, or an array of the distances. But yeah, you would be an object then, because I have to map to the edges to know like from what edge it is. But it would be better to get the distances here, since I have to calculate anyway, so that I can use the same distance later when I'm drawing the edges, so I don't have to recalculate here. Let me think. Oh, I can remove this stuff here. Instead of calculating the distance, but if I was gonna say subtracting or adding, but it's not very good. So the question is, should I return here the distance? You would have to be in a list of objects, I think. What do the edges have? Let me think. Maybe you can create. Yeah, I can create a thing on the edges themselves. But I think I'm just gonna try that and see if it works. So I'm just gonna create a property on the edges, and then I get it from here. Oh, actually, now that I think about it, I'm not using this thing here. So I can return from here. But it doesn't, like, it doesn't make a lot of sense because this obviously calculates the force, so, but I think it doesn't matter that much. It's not gonna change anything. Yeah, so now, and then I can use this on the other one to draw the thing. I could just get half or no, 1/4 of the 1/4 and 3/4 of the distance, and then I use that as the points. And the thing is how, because I need x and y, so that's the issue. Maybe instead of returning the distance, I returned an object. Well, let me think about this. That doesn't make sense. No, the only thing that I have to do is just calculate, obviously. So the distance is the magnitude, and then I can just subtract or add the coordinate of the two nodes. Now let me think about it. That doesn't make sense. Oh, maybe it does actually. Yeah, I just divide the distance by whatever amount, and then I just add to the coordinate of each one. Yeah, that makes sense, I think. Add or subtract, that's the problem. It's how do I know? I'm gonna try it out, obviously, but I guess I can know with a condition. I just put a check to see which number is greater or bigger, and then based on that I do the calculation. So that it is always on the middle of the line. Because obviously if you have the line here, and then I like this is positive x, then if I add to this one, it's gonna be, the control point is gonna be outside of the line, so I need to see which one is which, and then I subtract or add. Let me see if there is anything else here, and then I'm gonna try to figure out if there is any calculation for those via nodes. If there isn't, I'm gonna do the thing with the distance and see if it works. Hopefully it is that this easy to do it. So it does this thing, and then it falls back to the normal one, so align to. So first it moves to the point, the from point, and then it does the curve, which is the y, the 2 points. Yeah, so I would do this thing here. Hopefully it is this easy to do it. Okay, so let's see this one. I think when initializes this, so it's on the edge there. I remember seeing this somewhere. Yeah, where did I saw? I think it's on the edge that, yeah. So maybe it passes as options. That wouldn't make a lot of sense though. Maybe it does make sense. I think it does make sense. Because otherwise you wouldn't have, like, they wouldn't have logic to check to see if it's the type is dynamic or not. So it's probably something that it allows you to set on the options, and then there's a default value. Bezier edge. I'm trying to figure out if I can find anywhere that passes this, like, if I can see where the via comes from, or via, whatever you call that. Just see how that's selected. Also, it's here. I forgot that I saw this as well. And this is also, not sure if I should write this down somewhere, but it's important to know, I think, as well, because once I create the customization components, I'm gonna have to do this as well, probably. Every time you change the physics, you have to change this stuff, apparently. Oh, it makes sense, because then you're changing the size of the... You can change the size of the springs, and then that would mess up the breakpoints, I think. But wouldn't that fix itself by default? Because if you make the points based on the distance of the spring, or the two nodes. Yeah, I have a lot of questions related to the customization of the visualization. I think that's the hardest part, is figuring out how to synchronize both of them, and in what way to actually allow for the customization of the visualization. Because, like, how do I change the physics when I change through the event listeners of the custom components, or the component that is going to handle the customization for the graphs? It's coming from the edges handler create, and it passes that as properties. It's probably here somewhere. I think it's the beginning. I remember it comments everything else, so I could understand what's going on, I think. Blah blah blah. Yeah, here, so bodies, groups. This is the body, this is the image. Trying to see if I can find the create, if it calls the create function here somewhere, so I can see what is passing. But I think it's gonna be the options, and then the issue is I can't really see. But I'm like, could be the case that there is a default for the options, and then I would be able to see like what they choose as default for the breaking points. Well, this is the other thing that I have to think about, which is how to delete or reset the engine. Not sure how I'm gonna do that. Maybe it's just as easy as this, using this keyword here. I think I'm gonna have to do it like a class because of this as well. Because if I just destroy the app when the component mounts, just destroy the stage, I think it's kind of bad, because then it's not updating the engine with the new stuff, new information. Maybe that's why it's not working really well when I click the button, because then it's gonna render everything in the beginning, and then that would be working. But then when I click the button, it updates the components, but it doesn't update the physics engine. So the nodes don't. But yeah, the thing is that animation should show, but maybe they are showing, but they're just showing on the, like on the side here. Yeah, it doesn't do anything. And I think the thing breaks, maybe. Let's see. No, it doesn't do anything. Yeah, but if I put there, then it's gonna re-render. Now the problem is, yeah, I'm not gonna save this, and I'm gonna put it as dependency. See what happens. Yeah, I think they're gonna show up there. Oh no, it's working. Oh, interesting. This is the stuff that I was talking about, that it depends on the graph. Like, I don't understand really well why that happens in this situation. And now the thing here is also fucked up, so it doesn't work anymore because they are out of range. So the thing breaks down, the physics engine breaks down. So when they explode, because I guess it goes like really far away, and then it goes far, like it goes to infinity, and then the numbers break, so the engine has to break before that. So I guess it is working. The only thing that it isn't working is that it's exploding the thing, and I think it's because of the nature, the way that I did this, the joints there, because it's probably something about, but I'm not really sure, that all the nodes are connected to one node, so maybe that creates pressure on that node, or yeah, I don't know. Like, because the restriction of the nodes that all the other nodes are connected to is gonna make it so that they explode. But I don't understand the joint really well. I don't understand why. I understand that it creates the restriction, but I don't get it. I don't get why creating the restriction makes the movement of the node. That's the thing. So the problem happens, I think, when all the nodes are connected to one of them, and there's a bunch of them. But then why would that not happen here? I guess I can do the experiment and just see. I can create a bunch of nodes that connect to this one and see. I think that's what I'm gonna do. Yeah, but here now I can see that the force is working, probably, maybe. Oh, but it's not restricting the movement here. Oh no, it is. It's gonna be better to just... I think if I put the other force, then it's gonna stop. It's not gonna allow them to get really close from each other. This other one is the one that makes it stop, I think. But it's gonna be easier. I think first I should figure out the events before I do this, because it's gonna be easier to just drag the nodes to see what's happening. Well, first the line, then the events, then I go back to figuring out how to... yeah, figuring out what's wrong here. I think I'll be right back. So maybe it creates the via nodes through this node handler first. I guess it's just through this thing here. Like it is a... but the thing is that this doesn't say anything about the via thing. It just determines which type of class is gonna be, but there's nothing about the breakpoints. I think I understand. The problem is that because the lines are gonna curve over time, you can just use all the like the same thing each time maybe, because the distance is gonna change over time. Not really sure if that makes sense. Because if you're always using the positions as a function of the distance between the edges in the beginning, then when the edge curves, the distance is gonna be fucked up because it's not the same points anymore. Because the line's curved now, obviously, so you need these functions to calculate the distance. But I'm not really sure if I understand how they do it, like, or if there's a way to do it that doesn't require me to save the breakpoints, the via nodes. Maybe you should just ask ChatGPT. Oh, so it does create nodes in between the two nodes. Just makes them hidden. That's why. So it's like this grading. It's the same thing that the guy is doing on the coding train guy. Same thing, where he makes a bunch of nodes and then just hides the nodes, and then I thought it would be slightly different. And it looks like they do it in the same way. So I guess there isn't any way to like make this simpler. Like the biggest problem with this is that maybe I can make based on the variable like they do as well, and then I can allow people to select straight lines or with lines with curve, because the problem is obviously that if you have a very big graph, it's gonna make it more inefficient. So let's say, for example, we have a graph with 1 million nodes. Just by doing this, it's gonna multiply at least by 2 the amount of nodes, so it's gonna be 2 million nodes, and it's gonna be exponentially lower if the lines have these curves. If it is necessary to create the other nodes to work to make as control points. So that's the issue. So maybe I should leave it like the way that it is here now, and then I make this based on a condition that I'm gonna set up on the customization later. Ah, there we go. Yeah, so this one is also straight lines. Interesting. I guess it doesn't matter that the line changes over time, because what's gonna determine how the line changes is the points themselves. It's like the distance is always gonna be a straight line. So, and then you choose the breakpoints based on the algorithm, and that's what gonna create the curviness. So, it makes a lot of sense. So obviously what I'm thinking about doing, so I'm thinking whether or not it's worth it to do this now, or should I just ignore this for now and focus on other stuff like the events, because it is good enough, I think, to have the lines, and this makes more complicated. Like, my concern is that when I work on the other stuff, I'm gonna add a bunch of stuff through the options, and like, I think it's better to wait, I guess, until I'm working on the customization component, because I'm gonna make everything dependent on the variable anyway. So I need to, like, first structure how I need to create the system first that's gonna allow me to change the physics based on the events first. Once I have that figured out, then I think it's worth focusing on this stuff, because then it's probably gonna, like, if I do it now, I'm probably gonna have to change later because of the way that the customization is gonna work. So, but I think I understand now. Like, this is why I wanted to do this now, because now, like, I think I can move on, because now I understand how it works. So it's gonna be easy when I come back to do it. It's not that hard. So what I'm gonna do is just when I'm working on the customization, I'm just gonna add here like a flag variable, pass a flag variable, and then if the flag variable is true, then I save on the edges the breakpoints, like I'm doing with the distance here. Instead of saving the distance, I'm gonna save the breakpoints. And then if the breakpoints exist, then I'm gonna put them. The thing is that maybe it is better to make it based on the... Yeah, I think I have to make the calculation of the breakpoints based on the distance. So maybe it's better to just save the distance here for the edges. Because that's the thing. Yeah, I'm not really sure. I think every time that the physics engine changes the distance through the steps, is gonna change this one as well. It's gonna change the position of the bodies. But maybe it's better to just do it directly from here. But then the problem is that I'm gonna have to recalculate. That's the issue. Yeah, the question is whether or not the physics engine is gonna automatically change, because obviously it's gonna change the values of the bodies. So I assume that the distance is gonna change as well automatically. So if I pass this distance and I make the control based on this distance, it's gonna work, but maybe not, because maybe it doesn't update automatically. So let's say, for example, yeah, this is the issue. Like, if I calculate here the control points and then I pass them there, then I think it's gonna fail, because they are not connected to the bodies. They are always gonna be fixed points. The points are based on the distance, but then they're gonna be fixed. But if I make the calculation based on the distance, then because the distance is dependent, the value of the distance is dependent on the value of the nodes, then I think that is gonna update automatically. But maybe that's not the case because of the way that I'm structuring here, because it's returning from the function here, so it's just gonna be a value. I don't think it's gonna have like any connection to the objects, so it's gonna be the same thing. So I think that's probably what I'm gonna have to do, is just calculate from the, or I do it the other way around, obviously. Like, I pass the distance through this one instead of calculating here. I just pass this stuff here. I think that's what I'm gonna do. And then I just pass the distance here instead of using this one. and then I make that part of the edge, and make the control points based on the distance. So it's gonna be equal to a value, the control points, or something like that, which is gonna be an object, and the object is gonna have the x and y for. And then I was thinking about as well, like what kind of data structure I'm gonna choose. So it's gonna be like an object with the lists of the points, or something else, a list of objects, something like that. I think I'm gonna focus on the events now. I'll leave this for later. I'm gonna leave it like this, just so, or maybe, yeah, that was better. That doesn't complain. Now I'm gonna work on the events. And let me add the force first to see what happens, if it's gonna change anything. I think I can multiply by a scalar the vector. Alright, so it fucks up. Maybe if I put the same force. Maybe it's because of the value is fucked up. I think it doesn't change anything. Yeah, now it just removes the force because they are both they're counteracting each other, so it becomes 0. Well, I guess the thing that I can try as well is this, do the dampening thing. But like the thing that I don't understand here is that obviously on the video he does 2 different forces, and I think that creates the effect that it is like a elastic. The spring is elastic. So this is the stuff that I don't understand here how to do. I don't, because obviously if I put only one force it doesn't work. So how can I make them bounce? Let's see if it. Yeah, but here it seems like it doesn't work anymore. Oh, this one works. So it reaches the. I can see that it stops expanding. Or maybe not. No, it doesn't. Yeah, I'm not sure if I'm doing the correct way there. That's the problem. Obviously the force is working, because if I put a bigger force, then I think it is working. I think I'm gonna put the dumping there, or however you say that. Maybe I'm adding the force on the wrong nodes as well, but no, because then the edges would be incorrect. As there should be a limit to how much they. they extend. I think the issue is that I don't understand the revolute joint very well. I guess it's just because of the direction of the force. That's why. So the force is pulling away. So if I do the positive one, it's gonna work. But I guess it's positive because I'm adding the force to the second node. So. Yeah, but it's still weird because it doesn't make sense here. Like this one, yeah, I guess it's because of it's the thing that I was talking about before that I was confused by, because like if I just, what I'm doing now is just adding the one force, so obviously it's not gonna stop. So what makes it so that they reach an equilibrium here at some position, even when you stretch the node? Like, there should be some degree of flexibility, so you can stretch the node, the edge, but at the same time there should be a limit. So that should be equivalent to the k times x equation there. But I don't understand how I'm supposed to do that with the forces there. Like I should put another force maybe. The thing is equivalent. If there isn't any resistance, then because it's equivalent to the force is equivalent to the distance. So, and this is gonna be the thing that creates the limit. So if there isn't anything to stop, it's just gonna keep going because of the momentum. I think that's the thing. So let me think about it. Or yeah, if I decrease the force, it should probably work as well. Maybe that's the problem. Maybe just overcomplicating. Yeah, now they have, looks like they have a limit. Yeah. So I guess it is correct. It feels like it's off though. That's the problem. So otherwise you shouldn't. You should stop the ball from going there at some point. Yeah, let me think about it. It's just because of the way that I'm doing the... So -1 is correct probably. Let me work on the event listener. It's gonna be easier to figure this out. For the event listeners, I think I'm gonna create another file. Honestly, gonna copy as much as possible from this stuff here. Yeah, I don't like very much the way that this was done because of this. Like it initializes the... Yeah, this file I think is the worst out of the project, in my opinion. I don't really like the way that they did this, so... I want to see how it's implemented here. I think I'm gonna ask ChatGPT, and I'm going to, based on whatever ChatGPT says, try to search there to see how VJS creates the panning of the No, actually, it's not the panning that I want, but the movement of the nodes based on the click event. I remember looking into this stuff when I was trying to modify this to work with the ngraph library. But I don't remember really well. I think I didn't see when they initialized the click event to handle the selection of the nodes. I know there is the selection class, so maybe that's the place. The issue here is that it's sending the events there through the body, so like I understand that it's selecting the nodes, it's getting the nodes, but the actual logic for the click event's not there. It's gonna be somewhere else on the application that has the own method here and with the click events. So those places are gonna be the ones that have the logic to do the dragging. I think I know like a way to do it, which is just to like when the event fires off, you loop over the nodes and see, make a if statement to see if the x and y position of the mouse is equal or is inside one of the nodes. So you can calculate the area of the node based on the radius of the collider and the radius of the collider. You calculate the area. Then based on that, you see if the x and y is inside of the area. And it's gonna be a little bit annoying because of the positives and negatives, but doesn't seem that hard. And then based on that, if it is inside, then you change the position of the body based on the position of the mouse of the event, I think. The thing that I'm not sure about is what are the events, the best events to do that. Because I remember, I think I wrote this down, but I don't remember where. That somewhere it says that it should be the mouse down, mouse up, and mouse move, I think, events. And I don't understand really well how they are related to each other. Like, should probably start the thing on the mouse down, I think. But then from the mouse down to the mouse move, how does that work? I don't understand that. That's what I'm trying to figure out. Because obviously I want to implement on the best way, on the correct way to do it. So I think I have to figure that out first before I try to do anything. And it's very hard to figure out because these other examples here, they like it's all connected to the other libraries, like to functions of the other libraries, so it's confusing to understand. And they are using pointer up here. And then they usually use these flag variables to determine something else on the application. And you do some calculations based on the event. I think it's usually because you're going to put an if else statement to. It's kind of like it's happening like the other person did here with the player. Where you're going to put a condition on one of the functions. And then based on this condition, you're going to determine whether or not you're going to change the position of the body. And that's the reason why in most of these events you have these flag variables, I think. So the flags determine if the other positions are going to run or not. And they are synchronized with the events. Yeah. I think this here is the equivalent, because I think that in this example they are using SVG. So this is the equivalent of changing the physics of the body. This is the stuff that changes the position, I think, of the element. So it's pretty much like I was thinking about. You get the relative position and then you change, in my case would be the physics of the body, which is the XY of the body. And then you change that based on the coordinates of the event. It doesn't look like... The thing here is like, how are they managing the panning and the events on the elements themselves? I don't understand really well. Now let me see if I can find on the other files if there's any click events. The issue is that it might be some other kind of event as well. That's the problem, because they're custom events. So that's the thing. I don't think I'm gonna find it just through the click event. I'm gonna search for this one, select node. Let me see something. I'm pretty sure they have both events, so panning and selection. So it's gonna emit this one through the other one, I think. It emits the select node through the other one. So it's gonna be the event type, and then it's gonna emit here with the properties, which are the clicked items. So they are pretty much doing what I was thinking about doing. It's the same thing. I thought, like, I'm hesitant to do it like this, or to try to do it like this, because I thought it would be inefficient, or there might be a more efficient way, but I think they're doing the same thing. So first they get, like, they call this function which selects which item was, which gets which item was selected, and then based on that they trigger the other event, which is gonna be a custom event. And I think that's gonna determine. I think the custom event determines whether or not it's a panning event or the clicking. And maybe I'm gonna have to try to implement the event emitter as well, which I kind of don't want to do because I don't like very much. It's very confusing to me to use that. It seems very easy to implement actually, but it's just confusing for people that are learning. But maybe after I create the stuff, maybe after I work on the parser, I can create something that's gonna programmatically figure out. I wanna see. I think now I understand how they do it. The node selection. I wanna see how they do the panning now. I wanna see if I can find all of the event types of this file, and then I'm gonna search for those events on the other files. See if I can figure out. I think it's this one. So this is the general one. The other ones are specific to the elements. It's obviously hard to understand because like what it's gonna call this function, like who knows what part of the code is gonna call this. And then how all these flag variables work. But I think like I can kind of understand, so now I just have to search for this stuff and select nodes. It's gonna be easier to find. And that's the problem. I think this is for the customization component. Another thing you can do is just search for the name of the function instead. I think that might be better, actually. The commit and emit. Like the thing is that some of these events, I think they're not triggered anywhere. They're just like set up maybe. Not really sure if that's the case, but it's possible, I think. I won't tap here. Interesting. The problem is that I don't want to see the functions that trigger the event. I want to know what happens after the event was triggered. That's the problem. So I have to search for select because I need to know the function that is gonna be triggered. Oh, well, maybe the function is decided. Yeah, I think the function is decided by this, so it does make sense. It's passing the events and pointer, which is gonna be, yeah. So the pointer is the thing that's creates the properties. No. Oh, this is the event and the pointer creates the properties. So I guess I can't figure out based on the function that calls, because the function that calls is gonna pass the function that is gonna be triggered. And the pointer is just the mouse properties, or like the event properties maybe. Maybe not, so I don't really understand very well. The pointer is probably just the coordinates, and the event is the event that happened, but yeah, I think I have to, because I was confusing with the normal way. If you use add event listener, then it's gonna pass the function as the second argument, but it's not the case. Like, I have to search for the select event and figure out where, at what parts of the code, what parts of the code are listening to the select event, because they are the ones that are gonna set the function. And that's the problem. There isn't. Maybe we should open all of the files and look one by one. Maybe I should do like this, so it's probably the same thing. That's the thing, I remember doing this stuff in the past and I couldn't find some events as well. That's why I find it's very confusing. Oh, I think I remember is on the canvas. Maybe. Because I remember that the issue that I was having to translate is because of the way that the scale works, because of the translation. Like, here on VJS they are using an object to keep track of the scale and the translation, and then that's all you have to change. But then when you use it, WebGL, it's like the model, the MVP, model view projection, I think, that determines the... So the calculations are different, and I think that's why I was struggling to change this one based on the end graph one. And as far as I remember, the zoom event I think is on the canvas renderer, but I don't remember the click event, if I saw that or not. I think I just looked at the zoom event. But I think it's gonna be probably on the canvas. Would make a lot of sense. Yeah, here. This, so they're using this library here, I think, to handle panning. Pan move, pan start. But maybe, because I remember this is related to the touch events for smartphones, I think. So, not sure if that's related or not, or if this is for the click events. And the wheel event here. Oh, it's gonna be on the event listeners on the body. It's super confusing to figure this stuff out because the way that they do this. I guess it's just the nature of the thing because it gets complex and then it has to be done like this, but it's very annoying. Because those events there are the ones that are initialized on the body, but then I have to figure out like at what point it initializes the functions there. It's another complication. It's very annoying. It doesn't look like I'm gonna be able to find this. Oh, maybe here. This one is the one that was open before, I think. Oh, maybe not. Or maybe it is these functions here. I think I'm not gonna be able to find it. I think what I'm gonna do now is just watch some videos on YouTube. Part of me thinks that I should just implement the simple version, but part of me thinks it's kind of pointless because it's better to like understand first, because I think that right now if I try to implement the way that I'm thinking about, it's gonna fuck up the visualization because I don't understand really well how Pixie.js, like how to make Pixie.js draw everything correctly, and then if I should update the physics engine or not, and how to synchronize the two of them. So yeah, inside of the click event I have to, for the panning of the canvas, I have to figure out how the maybe it's better to just study the event system from Pixie.js. I think I'm gonna do that tomorrow probably. But it's also confusing. That's the problem, because I remember I already studied there, but I think if I study again, like I'm gonna have better understanding, because I remember that's I understood some parts of it. It changes the update function on the ticker, and it calls the classes from the plugin manager. And the classes are the thing that control what's gonna happen on the events. And I think those classes, they emit events through the event system in Pixie, and then the event system determines what happens. But I remember that on the initialization is very confusing. That's why I did the thing here. This part here is very confusing when it's initializing these runners, which are the things that are gonna manage all the systems. So when it initializes the renders, it calls this function here, and then yeah, this function it starts the events. Like this is the part that I don't understand really well, but it's gonna call for each system. Is gonna call this init function, because that's the one that is being emitted through this runner here. So the runner is a class that has the init, and then the init is this event system that uses the event emitter. And when you call this, then it's gonna call for each system that is initialized, it's gonna call the init function in the beginning. And then inside of this function is gonna call the context event, which is gonna go over all the systems again. Like this function here, this render runners context change. So yeah, on this context system, it calls this one, which makes it go back here, and then it just changes the name, and then calls all this the context function for all the systems again. So this part here is very confusing to understand how it works. But I think I was making progress last time. And then I think that the Pixie viewport changes. The way that it works is that it fires off the events inside of the update cycle of the ticker. And then those events are gonna trigger some functions based on the event system here. And then the event system, I think, is the thing that is gonna do the calculations to change whatever needs to be changed on the application to change the view of the app. So once I figure that out, then I think it's worth to build the event and then do the calculations, and then after I do the calculations, I see how to change the physics engine. Or if it is going to be necessary to change the physics engine, which I think it will, but it's probably going to be just the position. So I'm going to have to see. Obviously, it would be better if I could do both of them at the same time. So what I imagine is going to look like is just that you receive the event, which is going to have the X and Y coordinates. Then you do some transformation to get the relative coordinates. Then based on those coordinates, you move the visualization by triggering the events on the event system in Pixie. And right after that, or before, you change the values of the position of the bodies on the physics simulation as well. I think that's how it works. But it's confusing because then I don't know really all the relationship between the events yet. So that's another thing that's I'm breaking my mind to try to understand. Because I can't find it anywhere, like it's very hard to find. Like clean explanation and examples. Just say like what is the best way to do it. Because I think that usually this stuff is implemented by the libraries, so it's not very common for people to use it. I think that the only reason why I have to implement here is because I'm using 2 different libraries because the Pixie viewport doesn't work. Because I have to use another physics engine, so. But I'm not sure, maybe I'm doing something wrong as well. It's possible, so. And it's hard to figure out through here because the way that this is set, the events are set up here and on Pixie. I think it's probably better to just spend time trying to study the event system in Pixie and then do it from there. I think the reason why I'm hesitant to do it as well, to start working, is because I'm not really sure if I should use the event system or not, the event emitter class, because it seems like all of them use it, so. But like it must be, I think it's easier if you don't use it in the beginning, but the concern that I have is that later on, like once I have a bunch of stuff, I'm gonna have to spend a lot of time refactoring stuff. Because it seems to me that it would be a lot easier and more clear if I didn't have to do all of this connection of functions and events being emitted. Like if I just put the event here and then put the logic that is gonna happen, it's a lot more clear and easier to understand. But then later on, maybe it fucks me up in the future. Is there something that I don't know yet, probably, that I'm gonna have to deal with the visualization or whatever, or the physics engine. I think I'll do like this. Like tomorrow, I'm gonna study not sure if I'm gonna stream, but I'm gonna study the event system from Pixie. Then I'm gonna spend some time watching videos now after I finish streaming about how to. I'm gonna see if I can find videos talking about this stuff or explaining more, and then if by tomorrow I'm still not clear, then I'm gonna start trying to do it in the way that I'm thinking about it now, and go from there. But I'm gonna wait until it's very clear to me, this initialization here part. That's the thing. Once I understand very well what's happening with this part here, then I think I can start working on it. So yeah, I'm gonna stop here. I'm not sure if I'm gonna stream tomorrow, studying this stuff. Probably, yeah, I'm not really sure. But if I don't, this is what I'm gonna do. And then next time I'm probably gonna continue to work on this stuff. So